So Milne-Thomson method. Just a minute. Milne-Thomson's method to find what?
Recording.
No, you do not do from this. I am doing it. I am doing it from my side. Okay. So Milne-Thomson's method to find an analytic function when, this is one of the most important topics, when its real part, that is u, or imaginary part, that is v, or combination of u and v. Combination of real and imaginary part, combination of u and v, such as u plus v or u minus v is given. Okay, after taking this one, we will do the problems together. So this is Milne-Thomson method only. I have written it in detail. So Milne-Thomson method to find an analytic function when its real part. So what will happen sometimes when only u will be given, you will be asked to find out f of z. So we know f of z has u and v. U plus iv is f of z. So only u will be given. You have to find v and then f of z we need to do. Then sometimes what will happen, only v will be given. In that case you have to find u and then f of z. Sometimes u plus v will be given. You have to find u and v separately. Okay, u plus v, here u plus iv. So u plus v is given. You have to find the analytic function u plus iv. Sometimes u minus v is given. Then you have to find f of z. So there are actually 3-4 methods are there, and this is the easiest and simplest method. So we follow this method, Milne-Thomson's method. So what it is that, so we know we have f of z, w is equal to f of z is our, so let w equal to f of z is the an analytic function, or is the required analytic function.
हेलो।
हाँ बोलो।
पोलर फॉर्म हम लोग के सिलेबस में नहीं है क्या इस चैप्टर के लिए?
No, that is not in your syllabus. Okay. In syllabus it is not there. I have still told that just for your information only. It is not for your exam and or syllabus. So now Milne-Thomson method. Here what we do is we take w equal to f of z. This is an analytic function where we know where f of z is equal to u plus iv. Then here what we do is, this f of z is u plus iv, therefore we know when you find the derivative of this one, f dash z, you can have, see, f of z is u plus iv, in u you have xy, and in v also we have xy. Okay, so when you find the derivative of this f of z, means f dash z, when you do, you can find the derivative either with respect to x or with respect to y, not together. That means f dash z can be written as ux, means if I find the derivative with respect to x, then this will be ux plus ivx. When we do, when we differentiate that with respect to x, you will be writing here ux plus ivx. Or we can do it as, if we do that with respect to y, then this will be either, I mean uy plus ivy. So either of this you have to do. Not together, means you cannot write it as f dash z is equal to here ux plus ivy. This is not possible, because here what we are doing, we are differentiating one with respect to x, other with respect to y, so that is not possible. So here when we have f of z is uxy plus ivx, means u plus iv, firstly if you differentiate that with respect to x, then it is ux plus ivx, or if you differentiate that with respect to y, then it is uy plus iv. This simply means that df by dx. F dash means df by dx. This will be ux. So this is ux means partial derivative of that one with respect to x, and then partial derivative with respect to x, that of b. Okay, so either of this you have to write. This is the first step. Then what we have to do is, here in Milne-Thomson method, we will get, means our aim is, what is given, u will be given, u equal to, suppose cos x is given. Okay, so here what we have to do is, we need to find v. We have to find v also, and then we have to find f of z. So what we do here is, u will be given, this u is given, yeah, whatever, v is given, and if something is given, then you will find ux and uy you will be finding. Then using this one, so substituting this value in this equation, and then we apply something there. So first of all, we will be doing this one, then put x equal to z and y equal to 0 in, say, in f dash z. This is Milne-Thomson method. In every problem, this is what we do. In Milne-Thomson method means, put x equal to z in f dash z. Wherever x is there, put z, and wherever y is there, put 0. Okay, then what we are going to get is a function in z only, means f dash z you will be getting in terms of z, and then you can integrate that and you can find the solution. So if you are going by textbook method and all, here some plus minus confusion may be there, so I am not doing in that way. This is the simplest way. You have to just remember this one, put x equal to z, y equal to 0 in f dash z. Then later what it comes, I will show by an example. Say for example, suppose you have to find out a simple example. I'll take, just a second. Say one question is like this: construct an analytic function whose real part is x raised to 4 minus 6x square y square. I told there are 2-3 methods are there, but we are not doing all that. We will be doing this. So construct an analytic function whose real part is this. Okay, so construct analytic function means we need to get f of z. F of z we have to find out, whose real part is given this one. So here real part, so it is given u is equal to, this is given, x raised to 4 minus 6x square y square plus y raised to 4. This is real part. Then first of all what you have to do is, when u is given, just find ux and uy, because only that you can do. Ux means derivative of this with respect to x. So this will be derivative of x raised to 4 is 4x cube minus derivative of this term with respect to x. So when you do with respect to x, 6 is a constant, y square is a constant. So we will have 6y square into derivative of x square is 2x plus y raised to 4 derivative with respect to x becomes 0. Okay, so this is equal to, we will get 4x cube minus 6 to 12x y square. This is ux. Now uy means derivative of this with respect to y. So with respect to y, when you do, x raised to 4 derivative is 0 minus, here with respect to y we do, so 6x square constant and y square derivative 2y plus y raised to 4 derivative is 4y cube, which is equal to, just arrange it, so it is 4y cube minus 12x square y. So this is ux and uy. After this what you have to do is, so let, okay, I'll write here, let f of z is equal to u plus iv be the required function, required analytic function. Okay, therefore here f of z, we have f of z is equal to u plus iv. Then next step what you have to write is, therefore f dash z. f dot z is equal to, so as I told, you can write here ux plus ivx or uy plus ivy. Be careful, if you are writing here x, here also it should be x only. It should not be here x and here y. Okay, so ux plus ivx. Now in this answer, in here if you are looking, then here only ux and uy we have. Okay, so anyway, now we are going to find the analytic function. So construct an analytic function. So we are going to find analytic function. So we assume that f of z is an analytic function. Okay, then since f of z is an analytic function, by CR equations, what we can write, ux is equal to vy and uy is equal to minus vx by CR equations, using CR equations, Cauchy-Riemann equations, we have this. So because f of z is an analytic function, then ux equal to vy and uy equal to minus vx. Now in this one we got only ux and uy, means we need to remove this vx. Okay, vx should not be there. So what we can do is, this vx can be replaced by uy, minus uy. Okay, so this is ux minus I into uy. Okay, this is the easiest method to remember. So otherwise in textbook if you are looking, then here plus I into phi 1 of z0, phi 2 of z0 and all you will see, but I don't suggest that one. This is the easiest way. Here you will not be confused. So ux, and what we did, vx is replaced by minus uy. Okay, now so now we have here ux and uy. Okay, just put that value now. So this is f dash z is equal to ux. Value of ux is, we have 4x cube minus 12xy square. Being the first question, I am writing it here, ux, uy and all. Later on you can directly put x equal to z and y equal to 0 here itself, and then substitute the value here. Okay, so here now anyway write ux value minus I into uy is 4y cube minus 12x square y, and after that, so this is the step, this step, f dash z is ux plus ivx. Now Milne-Thomson method is, put x equal to z and y equal to 0 in f dash z. Okay, that is Milne-Thomson method. So I will write here, therefore by Milne-Thomson method, put x equal to z and y equal to 0, say take this as equation number 1, in equation number 1. Okay, here put x equal to z, therefore f dash z will become, x, replace x by z, so 4z cube minus 12 into, here x is z, y is 0, then minus I into 4y cube, y cube means 4 into 0 minus 12 z square into 0. Okay, so this is z into 0 and 4 into 0. So now what is there, this is 4z cube, this is 0, this will become 0 and this also is 0. Okay, so you are just getting 4z cube, so f dash z is equal to 4z cube. Therefore now we need f of z. So what to do? Just integrate both sides. Therefore f dash z, integrating both sides. Integrating both sides. What you will get? Integral of f dash z dz is equal to integral of 4z cube dz. So just integrate that one. So integral of f dash z will become f of z is equal to, here integral is 4 into z cube, in integral is z raised to 4 by 4 plus constant of integration. So you are getting f of z is equal to z raised to 4 plus c. So this will be the analytic function.